So good morning. I'm Sachin, and I'm working as a senior consultant, generative AI. And it's been a total of 9 years, 9.2 years of experience into the IT world and into AI and machine learning. It is 4+ years of experience that I've got. And especially into the generative AI, it's been like 2+ years of experience that I've got into building real world applications. So, into our organization, right now we are building many enterprise grade solutions that involve generative AI, retrieval augmented generation, and even agentic AI solutions. That's a quick intro about myself. Let me share my screen. One second. Yeah, I hope my screen is visible to everyone.
Yes.
Oh, yes.
Yes. Okay, then. Fine. So, like this to start with, into the generative AI, like we everyone know, like the very field of AI or machine learning is nothing but to train the algorithms or to to train them to an extent that they will be capable to do the human tasks with very easily. Okay, it all started with the rule-based systems first, and then it moved on to machine learning algorithms. So the machine learning algorithms, when we say, it generally encompasses of supervised machine learning, or where, like, let's say if you if you guys have got a data into an Excel sheet, which is in the row columnar format, where we know the number of inputs, and we know what the output is, like it is fixed, like the columns and the target variables, everything is fixed. You know what you're going to predict. So we call those particular systems as supervised learning systems. So to go into depth, like let's say you are trying to predict whether a person has a diabetes or not based on certain factors like age, his obesity levels, blood sugar levels, and blood pressure levels, and all other parameters. You want to know whether a person is likely to have diabetes or not, which means you know the target variable, right, guys? So you know a target variable, you are trying to predict the output based on some input features. So they are generally called as supervised learning features, because we are directly supervising, or we are directly allowing the machine to learn on all the features and then predict the output, right? So the core idea behind, so all of you might be knowing, when even in your school and college days, you might have studied about the equations of straight line, right? Which is given by y is equal to mx plus c. So in general, what happens there is, like, we draw a straight line and we are trying to calculate y, which is the output, and which is given by m into x plus the intercept, where m we called as the slope, which is the importance or the weight, x is the input feature, and c is the intercept. So in generally, what we do is, even into the machine learning, which is supervised learning algorithms, there are many types of algorithms which will try to predict what the machine is going to, learn. Okay. So there are, like, either you predict an output in the form of a classification, like whether a person has diabetes or not, and you try to, like, another use case of it could be what will be the stock price of a particular company or a firm going in the given the market conditions and in the next 10 years. So over a period of time, you are trying to study the trend and you are trying to predict the stock price of one particular organization or a company. So either, when we say supervised learning into machine learning, we either monitor all the inputs and try to predict an output, be it a classification or a regression algorithm, which I say we are trying to predict a continuous range of values. Okay, the other variant of machine learning is generally the unsupervised learning. In the unsupervised learning, what we generally do is, guys, given a certain group of, let's say, I am trying to predict the group of population which is trying to vote. I want to segregate them between 18 plus and below 18 as the voting population, right? Or even, let's say, I want to segregate between three categories of people who are 18 plus and who are below 18 and who are 60 plus, or the senior citizens. So there, given the mass of data, I would generally want to segregate the data into three different classes. That's an unsupervised problem, because there is no any target variable that you're predicting there, and you are trying to classify the group into three different classes. Okay, so that is a most probably a clustering use case where you segregate the data into into three different groups. One use case of unsupervised learning. Another use case of unsupervised learning could be like, let's say if you have got a huge range of data, let's say you have got 100 columns or 150 columns and millions of rows. So the very nature of the data is so huge that the machine will not be able to learn it in one shot. So how do we make the data short and yet not lose the very essence of the information from it? Like, we try to reduce the number of data by performing principal component analysis, is what we say. Again, an example of unsupervised learning. So all these natural language, you guys might also have heard about the natural language use cases, guys, where we try to predict the next word or next sentence, or also do the sentiment analysis of a particular tweet or any social media post of any celebrity. Okay, you are trying to predict the mood, or you're trying to predict the tone of the sentiment or the tone of the statement that any celebrity or any famous person has made. A sentiment analysis use case, again an example of unsupervised learning. So slowly, like, from the machine learning, supervised, unsupervised, natural language processing, NLP use cases, we then moved to the deep learning. Deep learning, what we call as like, it works. It took the very working algorithm of deep learning has taken an inspiration from the working process of the human brain, where, like, can anyone tell me what is the general functionality of the human brain? Like, there is an element. Can anyone guess it?
Neurons.
Perfect. Yes. So in our brain cells, we do have neurons that connect to one another, and they pass the information, like, from one neuron cell to the another neuron cell. So it is so quick that you guys will, it is very quick. Like, for example, you sense a danger coming to you, you immediately move away, or you immediately move side. How is that information processed? You see through your eyes, and you immediately move. That information processing is so quick that you even won't be able to grasp it, right, guys? So similarly, even machines, right, by the very connectivity of the neurons, we connect the machine network in such a layer that it will be able to pass the information, take the inputs, and then process the output. This network mesh is, and the technique of passing the information from one neuron to another neuron through and adjusting the importances and the weights, all this process is called as deep learning. So what happened is, when we advanced through all these technologies, like, the amount of data kept on growing. Okay. So the amount of data kept on growing so much that even with deep learning models, we were not able to handle the amount of textual data that was coming in. Then came the transformer architectures, which are nothing but the brain behind working of the large language models, is what we call. So you guys all might have used the chat gpt, right? So everyone is using chat gpt now, very alternative to the Google, even more than Google in some cases, right? So how is the working principle, of what exactly is the working principles of the GPT networks, or how are they working in the background? How do they process information? Even if you give any much of, there is some token limitations to the chat GPT that even you guys might have seen. How do they process information in one shot? How do they parallel process the information, so that the information or the next word or next token or next sentence is predicted by the LLM or the large language models, right? So that is the study. That is where the generative AI begins, guys. So in principle, if you know, for people who know Python, generative AI is nothing but calling the APIs of those particular LLMs. They are stored in their, like, there are many LLM service providers like OpenAI, Google, Meta, Grok, and Anthropic, all other very much range of models which are providing the large language model services, right? So I hope everyone knows who is the parent company of the ChatGPT. Anyone, like, who does not have the domain understanding of generative AI? Can anyone tell me who is the parent company of ChatGPT? Who owns it? OpenAI. OpenAI, perfect. And even Google has its own LLM, and even Google has a ChatGPT like interface. If you guys might have seen, okay, Google Generative AI. They also use their range of Gemini models to process the information, and you give any task to it, you get a response at the end of the day. Okay, so how are the LLMs trained to handle such a wide range of data and wide variety of data? The at the very beginning of it, when in the November 2022, when ChatGPT was released, it was more often text, core text in nature. It you only used to handle textual data. Okay. But now if you see, there are many reasoning models which are also multimodal in nature. You can feed not only textual data or image data, audio data, any kind of data you give in, they will process the information. They are also, encompassed with web search categories, just like Google. You give a information, the LLM will start thinking, and if it needs to do a web search and fetch the information, it does so. Okay. So that is how the LLMs have progressed through years, and this is where we stand now. Okay. And so going to the applications of it, guys, like we can use generative AI into creative arts, healthcare, which is a very big sector betting on AI, and even in the gaming applications. So in healthcare sectors, right, there are many wide range of applications within generative AI and more onto agentic AI now, where they are using personalized, patient recommendation systems where they can do everything. So, like in our organization, we were developing a patient companion use case wherein we were also taking, like we were developing the agentic AI use case also. Okay. So it used to take the symptoms of the patient. It used to take the medical history of the patient. It also used to analyze the blood reports of the patient. Okay. The analyzed with the analyzed blood reports, the patient symptoms and the medical history, it used to give us a certain diagnosis with some, confidence scores. Okay. What could be the potential diagnosis of a person, and based on the potential diagnosis, it also used to give the treatment recommendation plans. Okay. So we developed all this entire patient companion system so that the patient will have a very immersive experience, so that the patient will have very, good experience with the healthcare. Or even before the patient goes to meet a doctor, the doctor will have a very good history or background about what the patient has already went through and how he can personalize the solutions for him. Okay. Such are the use cases of agentic AI. So along with along with, the avalanche of benefits that it is offering, there are certain ethical concerns as well, especially with, healthcare system. Nowadays, clients are also seeking for transparency in the decisions. The people who are already working in generative AI might have, come across these concerns, ethical concerns, transparency, explainable AI, right, guys? You might have heard about it. Okay. So what the clients are now seeking is they want to know how the LLMs or the how the AI models are arriving at a decision given an input. Okay. So you give an input, the AI gives you an output. Even if you give something to ChatGPT, you give a question to it, it addresses it immediately. Okay. But how is it arriving at a decision? How is it arriving at those particular sentences? How is it arriving at a solution? How it is choosing those tokens from the very limits from its architecture is something very black box that is not yet revealed to the outer world. So clients are seeking clients are seeking explainability, especially in the healthcare domain, which is very risky. We have a good number of chances for the false positives and the false negatives, right, in the healthcare use cases. So both the false positives and false negatives are very, if I am to say, they're very dangerous given the healthcare. We cannot even afford to have false positives. We cannot even afford to have false negatives, right? So in such cases where where the very decision of the doctor is, like, even let's say if a doctor has to do one diagnosis, he will make sure he will have consulted all the other range of doctors and all the other range of blood reports, right? So there is a lot of data analysis that the doctor is doing manually to arrive at a decision, and that is backed by he even consults his seniors sometimes if at all he is in doubt for a particular diagnosis. But there should be no room for errors, or the error should be very minimal, especially when we are dealing with healthcare use cases, right, guys? So there, nowadays clients are also seeking the explainability. They want to know how the AI is arriving at a decision. Earlier these used to be called as the black box techniques, because there is immense mathematical calculations, calculus, linear algebra, vector algebra that go through and to arrive at a particular decision, and all of those things have been black box until now. Okay. So with ethical concerns also even the transparency and explainability in the AI is also a concern, and there is significant research also ongoing in those things. Okay, so what are the future trends, guys? AI is advancing very, into a rapid pace, and to cope up with it, the only thing is to update ourselves time wise. Even people working on generative AI need to update time now and then to keep up with the pace. Okay, so this is a quick overview on the generative AI. Does anyone have questions? If not, then I'll go to the agentic AI stuff immediately. I can also show some working principles, guys, like before going ahead, like how for people who do not have background on generative AI, I will also show you like certain couple of applications and how we call the open AI and all these things. I can just give a quick glimpse. 1 second, let me. If you guys can see my VS Code environment, you guys can see perfect. So like there are certain like this is the repository of my prompt engineering techniques that I've used. Okay, so I for the people who do not have any idea about the generative AI, how we call the APIs and fetch the response, right? So this is the example of it. Okay, so if you guys can see, like if you the same question, you have the user interface of the chat GPT where you can ask this question, what is the capital of the France? And like so you will get a response. But how do we call the APIs and the fetch the responses? How do we make use of Chat GPT and the versions of the Chat GPT models to fetch the responses? How do we give our enterprise range of data to the how do we manage our data? How do we leverage the frameworks available and how to fetch the responses through the Python code? This is an example. Let me execute very. This is very simple for people who know, but this is only for people who are do not have any idea about the generative AI. Yeah. See, the same question you ask to Chat GPT, you will get the same response. No worries. But how do we access the the background algorithm or the background model? There are wide range of models, like from ranging from it all started with GPT-3, which was trained on certain billion parameters. We went to GPT 3.5, we went to GPT 4, GPT 4o, we have O1 O3 models, we have GPT 4.1, and wide range of models. Okay, so all these models, guys, like GPT 4o onwards, they are all multimodal. They are capable to ingest textual data, image, audio, and other varieties of data as well. Okay, so but this is just a glimpse of how we can leverage the algorithm working brain behind the chat GPT and fetch the responses through the enterprise data. Okay, if I can share another example with you. 1 second, open my another folder. So we built a small resume analyzer for like the HR systems and all, a very basic example of the generative AI itself, okay, involving a very basic prompt engineering technique. Okay, so what this resume analyzer will do is it will help the HRs to shortlist the resumes for a particular job description. That's a very manual task, right? So let's see how we can leverage AI to automate this particular task. Okay, I'll just show you a very quick example just to get a glimpse of it. Okay, then we can move to agentic AI stuff. Okay, this is a very basic application for people who know generative AI. Okay, but how, like we all know, right, how the HRs will pick the resume and make it and shortlist it with in line with the job description. The HR knows what the job description is, and they also know what the resume contains, but they have to read through the resume. They try to find certain keywords, and if those keywords are there, resume is shortlisted. Or even some HRs make sure to read each and every stuff in the resume, and they make sure if the person has really worked on particular requirement and is very suitable for the job. That's how the resume shortlisting goes. But the HR, let's say if the HR has to shortlist 50 candidates for a particular job role, the task is very manual for them. The task will be very it will be very intensive to them. It will be very manual intensive. So there, let's see how can the AI based resume analyzer help the HRs. Okay, so what I'll do is I will upload a sample resume here, and this is the job description of the generative AI itself. Okay, so if people want to see what is the job description, let me give a note of it. Yeah, see. This is the job description, guys. This is they are looking for a generative AI engineer who is skilled and who knows various frameworks like LangChain, Llama Index, or equivalent frameworks. He also has some understanding of the vector databases, and he knows Git versioning and the GitHub and the enterprise integration strategies. Okay, so this is the job requirement, and I have uploaded a resume there. Okay, so let's see how the AI will help and AI will analyze this resume in line with the job description. Yep. See, guys, this is the feedback of the AI. So based on the resume, the AI has said the candidate has 9 years of IT experience with 4 years of specialization in machine learning and generative AI. Currently working as generative AI consultant in Capgemini since February. And prior to this experience, he also has an experience of data scientist and business analyst and proficient in Python, machine learning, Azure OpenAI, Azure Cognitive Services, various prompt and RAG techniques, hands-on experience with Azure AI Search, Azure DevOps, LangChain, and other Azure services, proven track record of implementing AI solutions, managing complex workflows, and improving business operations. What is the relevance score in line with the job description? The AI-based application says it is 85% suitable for this particular job role. These are the strengths and these are the suggested improvements to the resume. And this is the skills match and the gap with the job description. What is the match? It says the guy knows Python programming, generative AI, Azure AI, cloud deployment, and enterprise integration strategies, which is a good match. What is the gap? He does not have idea about certain frameworks, Llama Index or LangChain or equivalent frameworks, which the candidate has not explicitly mentioned, is what it says. The candidate has not mentioned any experience with version control and collaborative development using GitHub. Right? So, do you guys agree this will help the HR to shortlist in a much more, much more easier or much more quickly?
Hey, hi Sachin.
Yeah.
So this is amazing. Uh, it's mind blowing, to be honest. Yet still, I have a quick query here. So the relevant score, how it's been calculated? So is it using any sort of algorithm, or is it using? See, I'm an Elasticsearch engineer, so we do have
Mm,
certain
mm,
algorithms being
mm,
leveraged. I mean,
mm.
under the hood, the Elasticsearch leverages certain algorithm. So what's the algorithm here? So how
No, no.
how the relevant score is being calculated? Yeah.
We are not using, see, this was a basic application, right? So I have just used a basic prompt engineering to get the relevance score here. It's not using any algorithm or any technique here. So the techniques they're using, which the confidence scores or the relevance scores that you're talking of, I understand, like it's that's not implemented. This was just a basic application developed.
Got it.
Okay.
Got it.
Yeah, it's not using any algorithm. The relevance score is just purely on the prompting basis.
Makes
Yes.
sense.
Can we see that prompt? What you try?
Sure, very sure, please. This is it. Very simple, basic application, I would say. I just wanted to give the glimpse, right? How the uh, for people who are very new to this field, how can AI complement the current human roles and current job descriptions? I just wanted to give a brief idea. So this is a very basic application, I would say, not a very complex application. For people who know, I think if they look at the code, they'll be able to catch it. So from the PDF that we apply here, we are extracting all the text from the PDF and we are passing the text to the prompt along with the job description. Job description is what like we are also copy pasting here from the LinkedIn. You can use any Naukri or any LinkedIn portal, take the job description, paste it, then analyze it with the resume. Done taking a look at the prompt.
Sachin, one follow-up question. This is basic, right? This is not a RAG system, isn't it?
No. This is not a retrieval augmented system because I'm
Yeah,
not embedding the context here, right? I'm not training on the document. I'm not training on
right.
the document and I'm not drawing the context and I'm not embedding the context into the prompt. This is not a RAG application.
Hmm. Okay.
Yeah, as I said, this is a very basic, generative AI application just to give a demo of how AI can complement the how AI can automate the manual tasks and how AI can complement the current human roles. Because there is often a misconception, right, that AI will replace everyone, AI will replace everyone, right? So the very notion of it is AI will not replace everyone. There are some manual jobs that the AI is bound to replace, but most often AI right now is being developed with a very intention of complementing the human's job. It will automate the very boring tasks, redundant and menial tasks. It is going to automate that. If I am to give an example to you guys, right, there was right, we in our organization we were developing a retrieval augmented generation system, okay, for a for the tech support guys. They were working on a it was the L1 and L2 support guys who were working on a ticketing system. They had a list of knowledge articles. They used to manually read the knowledge articles, and then the client will raise a ticket, and whatever the client has asked in the ticket, they used to answer those questions based on the knowledge of those knowledge present in the or based on the KT given by the seniors, which was stored in the form of knowledge articles. Okay. Now this is a manual task, right? The engineer has to go, a senior or an expert, a technical support engineer will be able to answer those queries very immediately because of his experience. But what about the newly joined tech support engineers? He has to again read through all those documents, check for how his previous engineer solved the ticket, read for the content on that particular technical point that the client has raised, and then answer the question. So in all this due course, right, the tech support engineers usually have something called as SLA, right, service level agreement, or ETS. They generally give a 3 to 4 days of ETA or SLA for the tickets. All right, they give a 3 to 4 days of SLA for like basic tickets, and for P1 or P2 tickets the ETA is still higher, right? So this is a manual process, right? So what we thought is, let's automate all these things. Now what we did is we used retrieval augmented generation. We fed all the content from the knowledge articles to the algorithms. We trained on it. We generated a retrieval augmented system to draw context as necessary from these knowledge articles, and we reduced the ETA from 3 to 4 days to like a very few seconds or minutes. The AI was able to answer most of the queries, like all the P2 and P3 queries were all addressed, right? So this is the level of automation that AI can deliver. Okay,
One
just
question here on
just
your this project only.
yeah.
So when you say I have trained the generative AI LLM,
Mm.
uh, so how are you training? Like you are giving it as a context. So context means basically you will put that file. Let's suppose that is an Word file. I'll put that into one of the folder in my project, and I'll take a read that file in my code, and I'll put it into the prompt, right, as a context.
Correct.
Is that what you mean, or you have explicitly trained the model on that? Training
We
means you
began
will
with training.
bifurcate.
We began
Yeah.
with training. We began with fine tuning the model. If I am to use that particular word, we first, due to the very nature of the data, at the first, the client said the data would be static in nature. Okay, the data was not subject to change, frequently change. Okay, so if the data was static and the data was very intense, right, and it was very domain specific in nature. So first we went with the training the data, which I mean fine tuning the data. We used many techniques like PFT, LoRa, QLoRa, or we used all these techniques. We trained the model. Okay, but then the client said the data they want. There are certain program managers and project managers who want to update these knowledge articles on a day-to-day basis, and that's when we thought retrieval augmented generation, which means drawing the context from the data and feeding it to the pre-trained LLMs, will work.
I have another question. Sorry, I might be hijacking everyone's time, but then, what is the difference between, like, if you, what is the advantage of training? Because in does that mean that even if the knowledge is changing, the model will be able to answer? Is it like,
No, no, no.
is it
See,
like that?
when we mean to train the data, right? So the data which is very fixed kind of nature or static, which is not subject to change, and which is very domain specific, which means the LLM does not have knowledge on that particular data, and we switch to fine tuning in that case. But when the data is of dynamic in nature, when the data is ever changing, so continuously retraining your fine tuning pipelines will be very computationally intensive task, right, and even economically. So
Hmm.
there instead of continuously retraining the data every time when the data changes, we use retrieval augmented generation, which is what it draws the context, and along with the pre-trained knowledge of the LLMs, it gives the context. So prompt engineering technique with pre-trained knowledge of the LLMs along with the context, it will be able to generate the factually accurate responses for you, which is
Yeah.
what
So
the retrieval augmented generation does.
in RAG systems, basically we are not training the data, right? You are just
No,
giving it
in
as a
RAG
context.
systems, yes. The if you go by the word, right, retrieval augmented generation. If you
Mm.
look at these particular words carefully, what does it mean? Retrieval means you are doing context retrieval. Okay. So the LLM's capabilities are augmented with the retrieval process and the generation happens. This is what a retrieval augmented generation means. Okay.
Okay.
So the
And
LLMs
just
all
a
go ahead.
basic question, like it might be very silly question. Basically, here whatever prompt I'm giving, okay, this prompt and the, let's say this is a RAG system. You have defined one prompt, right? This prompt and the question which and the file which I have. If I give
Okay.
the same prompt
Hmm.
and file in my chat GPT, it will give the same answer, right? Because you are using the same GPT-4
I'm using
model.
the same I'm using the same prompt, but your chat GPT does not have a context, right? That you want to give.
I can upload that file also in the chat GPT.
If you upload the file, then ChatGPT, then they are like document-based RAG systems, right? You upload a document and you ask a question. So
Mm.
that probably there are some dedicated systems, right? They work on it because if you upload a document to the ChatGPT, maybe if you give the same prompt, it can draw the context or it may not. Even sometimes there are too much hallucinations as well. If you have observed it. Okay, so there are certain PDF based systems that are explicitly developed to do the retrieval augmented generation job or the RAG jobs. They can work better
Okay.
than ChatGPT.
Okay. But you are
Okay,
using the same model as GPT-4. The
GPT-4
behind,
model itself, right? So
yeah,
right now in ChatGPT as well, right? You have an option to use because by default I think it uses GPT-4 model, but if you exhaust the tokens, it will switch back to the previous version of it.
previous version. Yeah.
Yeah,
Okay.
that's how it is using. Yeah. Any more questions? I'll move to the agentic AI then.
And also Sachin, in RAG based like
Hmm,
solutions,
hmm.
I'm pretty sure validation is one of the biggest challenge that we have, right? So how did you
Definitely.
address the validation? Just to make sure that the data that you have provided versus
Yeah.
the requirement and validating it did match.
You mean to say the assessing the accuracy of the responses that
That,
the
that is
RAG
right. Yeah,
system?
that
Yeah,
is
yeah, I think we use there are many frameworks like RAG Eval, Ragas framework, and also they provide multiple frameworks to assess the answer factual correctness, and even the if the answer is what is the relevance score of the answer in see the answer the relevancy answer factual correctness and also the answer precision are measured both with respect to the question and with respect to the context. There is also the accuracy that measures how how best the context is given the user question and how best the answer is given the context. So their evaluation happens at two levels, one with respect to the context generated, one with respect to the user query.
got it. Okay, thanks.
Yeah. I think let me go to the agentic AI. I think we spent too much time on the agentic AI on the generative AI itself. Yeah, guys. Hope my screen is visible. So, as we all spoke about all these generative AI algorithms, like calling those models APIs, prompting in an appropriate way, like right. So, and then fetching the responses from the LLM, all these retrieval augmented generation systems, right? So, all these, so like as the industry is progressing, the amount of tasks are also increasing, and people wanting to club all those tasks into one particular use case are also getting increasing. Okay, so when the use cases are becoming task sensitive, task intensive, we there is something called as a new concept, a very currently right now in vogue and very buzzy right now is the agentic AI. Okay, so agentic AI is an approach is an approach in the large language models, is an approach in the large language model technique, wherein we are segregating one particular use case into multiple tasks, and for each and every task we are again calling the LLM APIs, and we are passing on the response. Now, I'll take an example of a use case that what we developed, which was the patient companion use case, which I quoted at the very beginning. So what we did there is we developed a system, an agent AI based solution for a hospital management system, wherein the first the patient the agentic AI will offer a it will collect the symptom collection agent first. So what the symptom collection agent will do is it will also have a human in the loop, wherein you can converse the AI in general. You can give your symptoms, it will go on asking you associated symptoms, and it will also collect your medical history. Then, if at all the patient has any blood reports to be analyzed, there was also an agent called as report analysis agent. So, report analysis agent generally we also had clubbed it with the OCR capabilities. Okay, OCR, if I am to say, optical character recognition technique, wherein it will scan your document and extract all that is present in your document. Okay, so the report analysis agent will extract all the text from your blood reports, feed it to the AI, and then generate you know uh, a report of what exactly is normal and not normal from the blood reports. Okay, so the agentic AI solution also gathered that input, and based on the patient symptoms, medical history, and the report and the blood report analysis, it gave certain diagnosis potential diagnosis. Okay, so now if you at all were to solve this by the RAG use case, if you prompt the LLM in one shot to generate all these tasks, there is very high possibility that the retrieval augmented generation systems will hallucinate, right? When I say hallucination, I what I mean to say is the LLM or the chat GPT, if you have also have observed, guys, the chat GPT will try to cook information like which seems very close to the near realistic answer, but is actually not a real answer, but is a like a falsified information or false information that looks like a real information. That is what we mean by hallucinations. So when if at all such a task task intensive use case, if you ever intended to solve by retrieval augmented generation, it will definitely hallucinate it. So agentic AI solutions will make it very segregated, very pointed to the task. Here the patient companion agent will only gather patient symptoms, analyze the symptoms. Next was the medical history agent, which will only collect the medical history of the patient. Report analysis agent will only perform the report analysis and diagnosis and the further potential treatment plans. Okay, which we have separate agents for that. Now what is happening here, guys? The the agent number one takes into account the patient symptoms and the medical history their own words, and they are very specific to their tasks, so that we are not mixing the LLMs with wide variety of tasks and huge prompting techniques. We are keeping it very specific. Okay, so the output of one agent serves as the input to the other agent. Okay, so based on this, it is a it is a sequential operation that is happening in the LLMs. The LLM number one takes patient input and it passes on the information. And so how will the diagnosis happen? Diagnosis will happen on the basis of the output of the three agents: patient symptoms, medical history, and the blood reports. So based on all these three things, there are certain potential diagnoses that the agent is doing, and based on those potential diagnoses, we are recommending few personalized treatment recommendation plans. So in a way, the hospital management system has wide variety of tasks. So aren't we making easy for the LLM to understand each and every task there, thereby segregating and making it crisp and clear at every step, right? That is what we are doing, right, guys? In the when we mean to agent when we mean agentic AI. So general agents are specifically used for task intensive use cases where the real segregation of the tasks, where each agent is dedicated to its tasks. So what all these agents do is they work in tandem, they work on a common goal, and they achieve it, right? So generally, how does agentic AI work is, first is the problem understanding, then is the goal setting, identifies what is the goal that it has to achieve execution of these goals and continuous learning process. When we mean continuous learning process, there are many ways to achieve it, like reinforcement learning with human feedback, also in the human in the loop, also including human in the loop, to assess the factual accuracy of the responses from the LLMs, all these things. But have we now understood what is the level of functioning between a retrieval augmented generation, normal calling of the LLMs, and the agentic AI stuff, right? So it is only to cater to the advanced use cases which are task intensive, which are task sensitive in nature, to address these tasks individually without having hallucinated response from the LLMs. Clear, guys? Like how, like the basic intro on the agentic AI, how does it work? So some of the benefits of agentic AI, like efficiency, reduces manual work, automates all the complex tasks, as we all spoke. AI agents are also capable of scaling. We can do higher grade of scaling as compared to the retrieval augmented generation. Adaptability, response dynamically to the real-time changes and unstructured environments. Collaboration, we can do n number of collaboration. Nowadays, we even have this agent-to-agent architecture from the Google and the MCP, Model Context Protocol. Okay, so you can integrate the agentic architecture with the, if you want to call multiple tools, right, for wide variety of your tasks. If you want an agentic AI solution to book a plane ticket for you or book a train ticket for you, it will have to manually go through the IRCTC website or even make my trip to book a plane. So such is the level of automation that you can achieve through agentic AI and the Google A2A as well. In the Google A2A, the only thing that happens is if there are two agentic systems, how to foster a collaboration between two agentic systems is what Google A2A achieves. And how many of you know about MCP, Model Context Protocol? Has anyone worked on it?
Yeah, I know the model MCP, but I didn't get a chance to directly work on that.
Yeah, there is also a recent development from the Azure. They have also developed a Azure MCP. Okay, so you let's say you have certain of the cloud services and you want an information, so you can initialize a Azure MCP and fetch the information from the cloud without having to manually go there and check each and every service. That is the level of automation that the Azure MCP has offered. Yeah, it would be worthwhile to once you can check it out once you're free. Okay, so all these agentic AI, MCP, agentic AI clubbed with MCP, right? Model context protocol and all. So they are all offering automation. They are all the tools to continuously automate all the tasks. You can, like, the MCP works on a client server architecture. Okay. You are a client, and the MCP server or the MCP framework that is built, serves as a server. So you ask a question, server fetches the response for you and gives it back to you. So it is just a HTTP call automated in through the LLMs is what is MCP, and the Google's A2A right now, agent to agent architecture. Okay. So, what are some of the differences between agentic AI versus generative AI? So, agentic AI is more autonomous and goal-oriented, real environment-based. It utilizes tools and APIs, as I called model context protocol, continuous adaptation, autonomous systems. So, all these agents, right? I took an example of a hospital management system where we developed a patient companion. So, all the agents there were independent. The kind of autonomy or the freedom that LLM offers to the individual agents to perform its own tasks, that makes LLM as a system more advanced in nature. So that is what we mean when we say autonomous systems, and they all have their independent decision making. Okay, as opposed to, unlike in generative AI or the typical traditional generative AI use cases and the retrieval augmented generation use cases, they are creative, output oriented, they are content based. They focus main on the type of content that you give them. If the quality of the responses is not bad, you either correct the prompting technique, or you also once revisit your content that you are using as a context. And there are no external tools that you're using when you're building a retrieval augmented generation system, unlike corrective rag and other systems where you draw the context even from the web services. They are done through some of the very basic tools, but we are not using the tools like we are using in generative AI, like MCP or even the function calling, tool calling. There are multiple services we use within agentic AI. The same are not, they don't go well with the generative AI or the retrieval augmented generation systems. So there is no real time response, there is no adaptation from the real time services, from the web search and other things. And they are more on the content creation, and they make decision based on the input patterns. As I said, based on your input document, the context is drawn and the LLMs produce a response. So these are the basic differences between how an agentic AI system works and how the generative AI system works. Yeah, applications of agentic AI, as we all know, autonomous vehicles from Tesla, and healthcare domains, finance, and customer service. Customer service right now has one of the major use cases in the generative AI. Okay, so these are the kind of jobs or the back office jobs or all these jobs. These are the jobs that are at the risk of getting replaced by AI. So customer service applications right now are using AI to a wide variety of extent to study how they can get the manual human work reduced and how AI can complement their work. Okay, and even in the finance, in the form of customer relation, in the CRM systems, in the healthcare, digitalization of all the health records, and autonomous systems. I think autonomous vehicles, you all know, like all the driverless cars and all these things. So these are again the extended version of the agentic AI automation and the systems. So we can do automated data analysis, supply chain optimization, or supply chain optimization also can be done. What is the right point of order? What is the point wherein the stock gets emptied? What should be the right point or order time so that the supply chain is not disrupted? IT security and self-healing systems. All again the extended use cases of agentic AI and automation. So, risks and challenges with agentic AI. So, as we said, risks there is definitely in any agentic AI system or in any AI system, bias, fairness, security threats, and loss of human control are definitely there. And challenges, as we said, transparency is again a burning issue in the industry that the industry is researching on. How can we induce transparency in the AI systems? How can we make it more responsible in nature? How can we implement the guardrails? What are the regulatory and compliance issues? How can we introduce accountability into the AI systems? These are definitely the challenges that the industry is working about. Has anyone heard about the explainable AI concept until now? Explainable AI is one of the top trending researchers in the industry. They are trying to make these black box algorithms more transparent. They want to know the decision process of the algorithms. That is where they want to introduce some amount of accountability into the AI systems. Yeah, so these are the best practices for implementing the agentic AI techniques, ethical AI development. We should, whatever agentic AI solutions we develop, we should involve certain guardrail implementations to check the language profanity and all these things. Robust security measures, continuous learning. We have to introduce reinforcement learning and human feedback to make sure that the agentic AI system learns continuously from its mistake, and how to control the human oversight as well. So these are again the basic architectures of the agentic AI system. Okay, can take a look at it. The data again is in multimodal in nature. The agentic AI system also has a memory, short-term memory, long-term memory, knowledge base, and this is the multimodal data infusion. As I initially said, all these models are now capable of handling the multimodalities like image, text, audio, and IoT data. Okay, and this is how it takes the information, processes the decision making, stores them in there. It also decides which information to be stored in the short term memory, which information to be stored in the long term memory, and the execution of those tasks and monitoring and again applying of the feedback. Yeah. So even guys, like when we also develop these, complicated agentic AI systems or be it complicated RAG based systems, right? So aren't we typically increasing the latency of the systems as and when you go on building complex applications, right? Let's say you train your algorithm on 1,000 documents. So if it has to fetch the context from all, if it has to do a search on all these 1,000 documents and then fetch the context for you, will it not increase the latency of the systems? So how to build a system that has low latency and high throughput is the so not only generative AI engineering, but we have to also couple it with some of the best software engineering practices to build scalable AI. How to introduce cache system, how to do the query intention, how to do query intent classification. So all these things will become very crucial when we are building a enterprise grade agentic AI system or even an enterprise grade RAG systems. Yeah. Future of agentic AI to build autonomous AI agents, AI and human collaboration, and next generation AI security. All these are the future trends of agentic AI. And again, as I said as well, the top topic is also on the transparency, explainable AI, and the introducing accountability to the AI systems. So all these things are top research trends. Have you got any questions at the end of this lecture? I hope it was not boring.